problem which kind of has some interesting results. So let's identify our u squared and a squared. And based on the patterns we looked at before, we're going to let u equal a secant theta this time. And so in this case, we're going to let x equal 3 secant theta. So let's start to build. X squared equals 9 secant squared theta. And then x squared minus 9 will be 9 secant squared theta minus 9. Okay, let's see what that looks like if you factor out the 9. That's going to be secant squared theta minus 1, and that's an identity. And so that turns into 9 tangent squared theta. So now if we put that under the radical x squared minus 9 will really just be 3 tangent of theta. All right, let's substitute everything in. But before we do that, it's important to find dx. So dx d theta, in this case, is 3 secant theta tangent theta. And so we'll move the d theta over when we sub it in. Okay. On to theta land. So for dx, we'll put in the 3 secant theta tangent theta d theta all over. On the bottom, that x cubed is going to be a 27 secant cubed theta, and the square root we know is 3 tan theta. Let's simplify this a little bit and see what it looks like. So we got 1 over 27 integral, the tangents cancel and the secants cancel, one of the secants, and the 3's will also cancel, so I'm left with just 1 over secant squared theta d theta. If I rewrite that, that is 1 over 27 integral of cosine squared theta d theta. In order to integrate this, you're going to need to turn to the identity from last class, which is 1/2 1 plus cosine of 2 theta. So if we go ahead and sub that in, I should be able to integrate fairly easily. So simplifying, I'll factor out the half, so I have a 1 over 54 integral of 1 plus cosine 2 theta d theta. Let's see what this looks like. We can integrate this pretty easily. So if we integrate it, it's 1 over 54. The integral of 1 is not x, it's theta. And the integral of cosine of 2 theta is going to be a plus 1/2 sine of 2 theta plus c. Now let's think about some of the issues we have in this situation. Remember our original substitution was that x was equal to 3 secant theta, so secant theta is equal to x over 3. We can draw a triangle from that just as before. Secant, remember, is hypotenuse over adjacent. So the hypotenuse is x, adjacent is 3, and by Pythagorean, the missing side is x squared minus 9. Okay, so the issue is this theta, but also the sine of 2 theta. So how are we going to deal with the theta? The theta, we have no choice this time but to write it as arcsecant of x over 3. Now, the sine of 2 theta is a little bit more troubling. You have to think back to pre-calculus and recall the following identity, which was a double angle identity, that sine of 2 theta can be written as 2 sine of theta cosine of theta. It's not critical that you remember that at this point, but hopefully it at least looks familiar. Okay, so all I need to do is find sine of theta, and looking at the triangle, sine of theta is this, and looking at the triangle, cosine of theta is 3 over x. So I'm all set to get back to x land after this. So in x land, it's 1 over 54. That theta can be written as arcsecant. You could also use arc anything, arctan, arcsine from the triangle, but we'll use arcsecant. The 2 and the 1/2 are going to cancel out. And so I'm just left with the sine of theta, which we said earlier was x squared minus 9 over x, and the cosine of theta, which is 3 over x, and then plus c. So this is our very, very interesting solution for this problem.